This is a very lengthy question, but it is an Olympiad question. Find the sum cos square 0 degree plus cos square 2 degree up to cos square 360 degree. We have to find out. That means multiple of 2, 2, 2, 2, starting from 0. So there are so many terms. It is 180 terms, 181 terms. So we will divide this into some series. 2, 3. I'll make 2 parts. How? First I am taking, this is same as your cos square 0 degree plus cos square 2 degree cos square 358 degree plus cos square 360 degree equals to, I am making into 4 parts. One is 0 to 90, that will be cos square 0 degree, cos square 2 degree. Here it will be cos square 88 degree plus cos square 90 degree. Next I'll make the series cos square 92 degree, cos square 94 degree up to cos square 180 degree. So before that certainly it will be cos square 178 degree. Third series is again cos square 182 degree plus cos square 184 degree. I am not writing all the terms, you must understand there are similar terms in between. Here it will be cos square 360 degree and cos square 358 degree is 270 degree. Plus 266 degree, 68 degree. And last is your cos square 272 degree plus cos square 274 degree, and last will be your cos square 358, last but one, and last is cos square 360 degree. So starting from 1, we'll write, before that let me write the values we know here. One is cos square 0 we know because it is cos 0 whole square, that will be 1. We know that cos square 90 we know it is 0. Next we know cos square 180. Cos 180 is minus 1, so this will be minus 1 square plus 1 again. We know cos 270, that is again 0. And we know cos square 360, it is 1. So these 5 values we have got. Coming to the first series. For the first series, I'll apply that cos 90 minus theta equals to your sin theta. And cos square theta plus sin square theta equals to 1. So it starts from cos 0, I am not writing, I am starting from here because we have taken it as 1. So cos square 2 degree plus cos square 4 degree. Here somewhere I'll get cos square 44 degree plus, when I'll write cos 46 degree, I can write cos 90 minus 44, that will 46, that will be sine 44 degree. So it will be sine square 44, and last but one will be your sine square 88 degree, and last but one will be sine square 86. Last is sine square 88. So if you see that cos square 2, sine square 88, they makes 1. Here these two makes 1, so on. So how to write this? I'll write that this is same as your taking the sum I is equal to 1 to I is equal to your how many terms are there? 44 terms are there, but I am writing this as I cos 2I sum. That means 2 with 2 into 2 4, 2 into 3 6, so on, and the value of I is your 22. Cos square 2I plus sin square 2I. If we take the sum, it will be 1. How many times? It will be 22 times. So here answer is 22. First series, the answer is 22. Series 1. Now coming to series 2. For series 2, what I'll write? First let me write what we have written. It will be cos square 92 plus cos square 94 plus cos, it is up to cos 176, because 180 we have taken as values, cos square 176 and cos square 170. This is 8 and this is 76. Here I will apply that cos 90 plus theta equal to your minus sin theta, or cos square 90 plus theta equals to sin square theta. So cos square 92 I can write that will be sin square 2, sin square 4. And what about this? There I'll apply cos 180 minus theta equal to minus cos theta, or cos square 180 minus theta equal to sin square theta, cos square theta. So cos square 92 will be same as your sin square 92, sin square 2 degree, 90 plus 2, sin square 4 degree, so on. And here will be again cos square 4 plus sin square 4, sin square 2, cos square 2. So many mistakes. Sorry. It will be cos square 2. So again I am getting a series summation of I is equal to 1 to I is equal to 22. Again it will be sin square theta plus sin square 2i plus cos square 2i. So what is the value? It will be 1. How many times? 22 times. The series is 22. Now coming to series 3. Series 3 equals to cos 182 plus cos 184, 270 I have already taken. So cos square 168, and before that 268, before that it will be cos square 266. So here I'll apply again cos 180 plus theta equals to minus cos theta, and cos square 180 plus theta is equal to cos square theta. So it will be in this side from left, and from right side it will be your we can write cos, it will be 3 pi by 2, the 270 minus theta equal to your 3 pi by 2 minus theta equal to minus sin theta. And when I'll take square, it will be square. So here this cos square, and it will be cos square 182 will be cos square 2 plus cos square 4 plus cos square 6. Here somewhere cos square 44. Then it will be all sin square. Sin square 44 up to your sin square 4 plus sin square 2. This is again a series of I is equal to 1 to 22. I is equal to 22 cos square twice I upon sin square twice I. This gives us 22. Now coming to fourth series. So that will be same as your second series. It will be cos square 272 plus cos square 274 here cos square 358 cos square 356. So here we'll apply, how much will apply? Cos 3 pi by 2, 270 plus theta. 3 pi by 2 plus theta, we are in fourth quadrant and cos is positive here, it will be sin theta. If I take square, so it will be sin square, and here for all the last 22 terms we'll put cos 360 minus theta equal to cos theta, or cos square is equal to cos square. So I'm not writing all the terms, you must have understood what I am doing. So first one will be your sin square 2 degree plus sin square 4 degree, so on. In between sin square 44 will be there, cos square 44 will be there, and last term will be your cos square 4 plus sin square 4, cos square 2. So again summation I equals to 1 to 22, it is your sin square twice I plus cos square twice I equal to 22. So the four series all are 22, 22, 22, and this value of this 5, your cos square 0, this was 1, cos square uh, here, cos square 0 is 1, cos square 90 is 1, 0, this is 1, this is again 0, and this is 1. It was, the value was how much? 3. So 3 plus 22 4 times, the sum equal to, so final answer I am writing. So cos square 0 degree plus cos square 2 degree plus cos square 4 degree up to cos square 358 degree, then cos square 360 degree equals to your 22 into 4 plus your 3. So 91 is the answer. Thank. Again, we have taken the trigonometry question, identities. Can you prove this? Cos x over 8 multiplies cos x over 4 multiplies cos x over 2 multiplies cos x equal to sine of 2x over 16 times of sine x over 8. So I'm writing the left hand side, that is cos x over 8, cos x over 4, cos x over 2 multiplies your cos x. So on the right side, I can see in denominator a sine x by 8. So I'll multiply both in the numerator and denominator 2 sine x over 8 and 2 sine x over 8. And it was cos x over 8, cos x over 4, cos x over 2 into cos x. Now we'll apply your double formula for this. That means we know that sine 2y theta is same as 2 cos theta into sine theta. So this is our form. We will convert to this one. So sine x by 8, when cos x by 8 multiply, it will become your sine x by 4. So in the numerator, I am getting this one. The denominator, it is 2 sine x over 8. So again I will multiply it 2 here, both in the numerator and denominator. So that this will be, again applying the same formula, it will be sine x over 2. So it will be sine x over 2 into cos x over 2 into cos x, and in the denominator now I have got 4 sine x over 8. Again we'll multiply 2 and 2 here, so that this I'll make this formula, that will be sine x into cos x. Now it is 8 sine x by 8 in the denominator. Next what? Again you can guess. Again 1, 2, both in the numerator denominator, so that the numerator will become sine twice x. We have already got this right hand side, and it is 16 x over 8. So I hope you will find the sum of sine 1 degree plus sine 2 degree plus sine 3 degree up to sine 90 degree. We know that sine 90 is 1. So we can find the sum of 2 sine 1 to 89. We can add 1 after that. So let S be sine 1 degree plus sine 2 degree last is your sine 89 degree. Or the same as can be your sine 90 is same as your cos 1 degree. This can be cos 2 degree 88, and here your cos 88 degree and cos 89 degree. So I am getting the value of S taking in term of cos. So I am not writing degree at each step. It is understood that it is your degrees cos 2, cos 3 up to cos 89. So both in the left hand and right hand, I will multiply sine half. So half multiplying with sine half degree into, it is degree, I am not written a step, at each step I am not writing degree. It will be sine half into S equal to sine half cos 1 plus sine half cos 2 up to last will be sine half cos 89. Then I'll apply the product of sum formula, that will be 2 sine A cos B equal to sine A plus B plus sine A minus B, or if it is sine A sine cos B, then it will be half this. So applying formula for each term, we'll get sine half into S equals to, here it will be half sine A plus B, half plus 1, that will be sine 3 by 2 minus sine 1 over 2 half. Second term will be half 2 plus half, that will be 5 by 2 sine 5 by 2 minus sine 3 by 2, so on. And the last term will be your sine 89 plus half, that will be 179 by 2 minus sine half. It's not half, it will be sine 89 minus half equal to 87.87 half, what will be 8177 by half. So sine half multiplies S equals to, if you will see this series, you will find that sine 3 by 2 minus 3 by 2 cancel with sine plus 3 by 2. In the same way, 5 by 2 will be cancelled with the second term, and this term will be cancelled by the previous term. So what will remain? It will be half into minus sine half, and there plus half sine 179 by 2. Now S will be half sine 179 over 2 minus sine half, full divided by sine half. So we'll simplify this. S equals to half sine 179 by 2 sine half, and second term will be half sine half over sine half. So it will be cancelled. So it will be half sine 179 by 2 over sine half minus half, or S equals to half sine 179 over 2 can be written as sine 180 by 2 minus 1 by 2. 180 by 2 means it is nothing but your 90 degrees. So sine 90 minus theta is cos theta, we know. So this will be half cos half over sine half. So that is your cot half. So half cot half minus half. So this was up to 89 degree. If I want to take S equals to sine 1 degree plus sine 1 2 degree plus sine 3 degree plus sine 89 degree plus sine 90 degree, I'll add 1 to be half cot half minus 1 minus half plus 1. So the answer is half plus half cot half. The question is, solve the question sin x plus sin 2x plus sin of 3x equals to cos x plus cos of 2x plus cos of 3x. And of course this interval is given that x is equal to 0 to 2 pi. We have to solve this equation in this interval. So rewriting this equation, arranging a little bit, I'll get sin x and taking sin 3x with sin x and sin 2x I'll make separate. Same pattern in your right hand side, cos x plus cos 3 times of x plus cos 2x. So then we'll apply the formula sin A plus sin B in the left hand side. Sin A plus sin B equals to 2 sin A plus B or 2 into cos A minus B over 2. And for cos A cos B, cos A plus cos B, will apply 2 cos A plus B by 2 multiplies cos A minus B by 2. So in the left side, I'll write, instead of sin x plus 3x, I'll write twice sin x plus 3x over 2 into cos x minus 3x over 2. Or I can write 3x minus x by 2 and plus sin 2x as it is. In the right side, it will be these two. I'll apply the second formula. So it will be 2 cos x plus 3 times of x by 2 into cos x minus 3x over 2 plus cos 2x. So on simplification, I am getting 2 sine twice x and cos, this is minus x, cos minus theta is same as your cos theta, so it will be cos x plus sine 2x. On the right side, I'll get 2 cos 2x and cos x plus cos 2x. Now observe very carefully, in the left hand side I am getting a sin 2x common in both the terms, which I'll take outside. So in the bracket I'll get 2 cos x plus 1, and on the right side in the same way I am getting a cos 2x. So cos 2x, there I am getting 2 cos x plus 1 equals to 0. Now taking to all one side, I'll get sin 2x into 2 cos x minus 1 plus 1 minus cos 2x So 2 cos x plus 1 equals to 0. So next I'll take common 2 cos x plus 1, which is a common factor in both the terms. Then within bracket I'll get sine 2x minus cos 2x equals to 0. So there are two factors now. One is either 2 cos x plus 1 is 0 or sin x sin 2x minus cos 2x equals to 0. So when 2 cos x plus 1 equals to 0, I get 2 cos x equals to minus 1 or cos x equal to minus half. Minus half means this is cos 2 pi by 3. Now taking the formula for your solution formula, cos, when cos alpha is equal to cos theta, that time we write that alpha equals to 2n pi plus minus theta when n is an integer. So here I'll write cos x equal to cos 2 pi by 3. That means x equals to 2n pi plus minus 2 pi by 3. So this is one solution. Next coming to second one. So here I'll get sin 2x minus cos 2x is 0 or sin 2x equals to cos 2x, or dividing throughout the cos 2x I'll get tan 2x is equal to 1, or I'm getting tan 2 times of x is equal to 1 means tan pi by 4. Then I'll recall the formula, that is when tan alpha is equals to tan theta, we get the general solution alpha equals to n pi plus theta. So I'll get 2x equals to n pi plus pi by 4, or x equals to n pi over 2 plus, of course when n is an integer I should mention, plus pi by 8. So this is another set of solutions. Now let us see the limit or the interval x is equal to 0 to 2 pi. So here I'll put n is equal to 0, 1, 2, 3, 4, so on. When n is 0, I am first getting this set of solution. When n is 0, I am getting pi by 8. X is equal to pi by 8. And when n is equal to 2, n is equal to 2, I'll get pi plus pi by 8, that will be 9 pi by 8. And again it will be 3, it will be 3 pi by 8 plus it will be, on simplification I'll get 5 pi by 8. Then your 9 pi by 8 I had got. Then next will, I'm arranging it, otherwise 5 pi by 2, 8 should come last. Then your 13 pi by 8. So when n is equal to 0, 1, 2, 3. It cannot be more than that because we have to see the interval. So these are the values for second set of solution. And for the first set of solution, it was x was 2n pi plus minus pi by 3. So here I'll get only n is equal to 0 and 1. So x equal to when 0, it is your pi by 3, sorry 2 pi by 3, it was 2 pi by 3, and when n equal to 2, it will be 4 pi by 3. So we are getting 6 set of solution. So let me write solutions here. So the solutions are pi by 8, 5 pi by 8, 9 pi by 8, 13 pi by 8, then here you will go up to n is equal to 0, 1, 2, 3. You cannot go beyond that. So next is here 2 pi by 3 and 4 pi by 3. In a triangle ABC, prove that sine square A plus sine square B plus sine square C is less than equal to 9 by 4. So this question again involve 2-3 part questions. So please watch the video from beginning to end so that you can learn many concepts or recall the concepts. First is your, I'll write sine square A plus sine square B plus sine square C. I'll prove that this equals to 2 plus twice cos A cos B cos C. You also try to prove these identities. First I'll prove this. So for this I'm taking the left hand side, sine square A plus sine square B plus sine square C. I'll replace one by one with cos formula. Sine square A equals to 1 minus cos of 2A by 2. Next is 1 minus cos of 2B over 2, or this is half of 1 minus cos 2C, cos square C. Then you can simplify. I'll get half plus half plus half. That will be 3 by 2. And each is negative half. I'll take common. It will be cos twice A plus cos twice B plus cos twice C. Or sine square A plus sine square B plus sine square C. We got 3 by 2 minus half of cos 2A cos 2B cos 2C. Next, coming to cos 2A, the right hand expression, cos 2A plus cos 2B plus cos 2C. I'll convert this twice B double angle to single angle. So what I'll take sum of product formula. So 2, it's a product of sum, cos 2A plus 2B by 2, that will be A plus B, into cos 2A minus 2B by 2, that will be A minus B, plus cos 2C. Now cos A plus B equal to cos 180 minus C, because A plus B plus C makes 180 degree. So that will be minus cos C. So I'll write minus 2 cos C into cos A minus B And here cos 2c I'll convert into cos c, that will be 2 cos square c minus 1. So from first two terms I can take 2 cos c common, then minus 2 cos a minus b will be left, and from the second term cos c will be left, minus 1. So you could guess. Now I'll take minus 2 cos a minus b, and this cos c I'll write as negative of cos a minus b. It's not 2 cos a plus b. This is equal to 2 cos c, taking minus common, it will be cos a minus b plus cos a plus b. Then I'll get 2 cos a cos b minus 1. So whole thing is becoming now minus 1 minus 2 cos a cos b cos c. Now I'll replace this here, this one. So I'll get sine square a plus sine square b plus sine square c equals to 3 by 2 minus half. Instead of cos 2a plus cos 2b plus cos 2c, I'll put this one minus 2 cos a cos b cos c. Let us simplify a little bit. Sine square a plus sine square b plus sine square c equals to 3 by 2. This will be multiplied plus 1 by 2. This will be multiplied here. It will be 2 cos it cos b. It will be 4. Sorry. Very sorry. It will be 4 here. This will be plus half into 4 cos a cos b cos c. So I am getting sine square a plus sine square b plus sine square c equal to 2 plus 2 cos a cos b cos c. Now coming to inequality. So cos a cos b cos c is your less than equal to 1 by 8. This I have a video to prove this, so you can click on the, you can learn from this. Click at the end, click on the video at the end. So 2 cos a cos b cos c is less than equal to 1 by 4. Now 2 plus 2 cos a cos b cos c is less than equal to 2 plus 1 by 4. So what is it? It is nothing but your sine square a plus sine square b plus sine square c. So I can write sine square a plus sine square b sine square c is less than equal to 9 by 4. Question from International Math Olympiad based on number theory or algebra. This question from series, but it is also based on trigonometry. For every natural number n and for every real number x, there is not in form of x equals to k pi over 2 power t, where t is 0, 1, 2, 3, n, and k is an integer. Prove that 1 over sine 2x plus 1 over sine 4x plus 1 over sine 8x up to 1 over sine 2 power nx equals to cot x minus cot 2 power nx. We have, if you have watched my video regular, that means sometimes you must have seen I have solved some questions based on this telescopic series. So here also it is a question from that type. So let's find the solution. Here for this telescopic sum, we need a key or we need a formula. So here also we will write the formula. First we should understand what is this statement. This is x equals to your k pi over 2t. It is not in the form. That means 2, it cannot be, x cannot be in this form. That time it will not be defined, and t equals to 0, 1, 2, 3 up to k, up to n, and k is an integer. Here it is an integer. That means at that time it will not be defined. Okay. So first let us write the formula. What will apply here? That is your 1 over sine twice x equals to cot x minus cot 2x. Let us check whether it is correct or not. I am writing the right hand side. So cot x minus cot 2x equals to, I am changing into cos and sine. So this will be cos x over sine x minus cos 2x over sine 2x. So if we take the LCM, it will be sine x, sine 2x. In the numerator, I will be getting sine 2y x cos x minus cos 2x sine x. Whose formula is this? This is nothing but your sine 2x minus x. So cot x minus cot 2x equals to sine your 2x minus x, that is sine x over sine x into sine 2x. So you must be noticing that we are getting 1 over sine 2x. So each term sine 2x, 1 over sine 4x will be written in with the binomial in cot function. Then only we will get the sum. So I am writing, this will be your cot 2 to the power kx minus cot 2 power k plus 1x equals to your 1 over sine 2 power x. You can also verify with the same formula what I have applied here. We can verify. So this will be cos 2 power kx over sine 2 power kx minus cos 2 power k plus 1x over sine 2 power kx equals to, LCM is sine 2 power kx into sine 2 power k plus 1x. Here it will be sine 2 power k plus 1x in multiplies cos 2 power kx minus cos 2 power k plus 1x into sine 2 power kx. Or I'm getting cot 2 power kx minus cot 2 power k plus 1x equals to, here sine, same formula will give, apply 2 power 1x minus your 2 power kx divided by sine 2 power kx into sine 2 power k plus 1x. By simplification we'll get here sine 2 power kx and here sine 2 power kx into sine 2 power k plus 1x. These two will be cancelled. So we are getting 1 by sin x. Or changing the side, I can write 1 over sine 2 power k plus 1x equals to cot 2 power cot 2 power k. It is not 2k. By mistake I have written 2 power kx. Here also I was going to write a wrong thing. It is cot 2 power kx minus cot 2 power k plus 1x. So we got the formula for series. As I told, for telescopic sum you need a formula for k's term. So next, coming to k is equal to 0. When I'll take k is equals to 0, 1 over, this is the hint you can get that here it is written t will be from 0 to, and so you can think of, say this value will start from 0. So here k is 0, I'll write, if we put 0 here, it will be just sine 2x, 1 by sine 2x. And on the right side, if we put 0, 2 to the power 0 is 1, so this will be cot x minus your k is 0, cot 2x. So we already proved this, and this was the first statement. And next, when k equals to 1, when k equals to 1, I'll get 1 over sine, let me write the formula, show the formula, 2k is equal to your 1, then it will be 4x, 2 power 2 is 4, here I'll get 2 power 1, so cot 2x, and here cot 2 power 2, that will be cot 4x. And when k equals to 2, I'll get 1 over sine 2 power 3, that will be 8x, and here it will be cot 4x, making 2 here to do 4, and here 2, 3, so it will be minus cot 8x. So on. K is equals to n minus 1 and k equals to n. When I'll take k equals to n, certainly I'll get sine 2 power nx equals to here cot 2 power n minus 1x minus cot 2 power nx. For n minus 1, certainly we'll get here your minus cot 2 power n minus 1x, and here cot 2 power n minus 2x, a positive for this. And in between there are so many terms, 16x, so on. Here it will be sine 2 to the power n minus 1x. Now we'll take the sum of this series. Taking the sum, adding all the terms. So here these two are cancelled, and here it will start from your series 1 or 1 first term. For 2x is cancelled minus plus. Here this will be cancelled. So it will be clear to our mind that they all will be cancelled. Only this one last one and first of first one will be left. So let us write the series now. So 1 over sine 2x plus 1 over sine 4x plus so on 1 over sine 2 power nx equals to cot x minus cot 2 power mx. Hence it is proved. 2 sine pi over 22, 3 pi over sine 3 pi over 22, sine 5 pi over 22, sine 7 pi over 22, and sine 9 pi over 22. We have to find the value. So let's rearrange the terms in this way. So this is equal to 2 sine. Here I am writing your 11 pi minus 10 pi over 22. That means pi over 22. I am writing 11 pi minus 10 pi. Similarly, the second term I will write 11 pi minus 8 pi. Now you can guess the next term. It will be 11 pi minus 6 pi by 22 sine 11 pi minus 4 pi over 22, and the last term is sine 11 pi 2 pi over 22. So 11 pi over 22 means nothing but your pi by 2. So this is equal to 2 sine pi by 2 minus 10 pi by 22, or I can write it 5 pi by 11. Next is sine pi by 2 minus this will be 4 pi by 11 sine pi by 2 minus 3 pi by 11 sine pi by 2 minus pi by 11. Last one is sine pi by 11. All the formulas we know, that is it will be converted to cos, because 90 minus theta is cos theta, sin 90 minus theta is cos theta. So it will be cos 5 over 11. Next will be cos 4 pi over 11. Next is cos 3 pi over 11, cos 2 pi over 11, cos pi over 11. Now it seems a familiar question. So I'll arrange in this way. First is 2 cos pi by 11. Increasing order the value of this theta, I'll write cos 3 pi by 11, cos 4 pi by 11, and cos 5 pi by 11. We know the trick. That is, I'll multiply with a sine pi by 11 both in the numerator and denominator, or I'll divide one sine pi by 11 both in the numerator and denominator, into cos pi by 11 is 2 pi by 11 cos 3 pi by 11 is 4 pi by 11 and cos 5 pi by 11. So in the next step, I'll take this sine pi by 11 cos pi by 11. It will become sine 2 pi by 11 sine 2 pi by 11, and there is a 2 cos pi by 11. So it can be made into a formula, double formula, but we need a 2, so I'll multiply. In the next step, I'll multiply a 2 both in the, will be 2 here 2 sine pi by 11. Next I'll make into cos sine 4 pi by 11. It is 4, by mistake I've written 2, it will be 4. It will be sine 4 pi by 11, and I'll arrange cos 4 pi by 11, I'll keep together, and cos 3 pi by 11, cos 5 pi by 11 separate. And here there was a 2 sine 11 in the denominator. Then again I'll multiply 1 2 here and 2 in the denominator, and this I'll make into sine 8. This will be your sine 8 pi by 11 3 pi by 11 and cos 5 pi by 11 full over 4 sine pi by 11. In the next step, I'll change this 8 pi by 11 as sine pi minus 3 pi by 11. So this will be sine pi minus 3 pi by 11, because it makes you 8 pi by 11. This makes you sine 3 pi by 11. Sine pi minus theta is same as sine theta. Cos 3 pi by 11 into cos 5 pi by 11. Sine pi by 11. Now again I'll multiply 1 2 in the numerator and denominator, so that this will becomes your sine 6 pi by 11 8 sine pi by 11. So next we will multiply again 2 both in the numerator denominator. So it will be, this will makes you sine, it is, again I'll change, sorry, very sorry, I'll change here. I'll make it 2 sine, it will be pi minus 5 pi by 11 and cos 5 pi by 11. Here 16 sine pi by 11. So we are getting 2 sine 5 pi by 11 into cos 5 pi by 11, 16 sine pi by 11. So this makes you sine 10 pi by 11 by 16 sine pi by 11. So in the next step, sign we'll change the sine 10 pi as pi minus pi by 11, pi minus pi by 11, and here 16 sine pi by 11, and pi minus theta is same as sine theta. It will be sine pi by 11, sine pi by 11, and 16 is there. So the answer is 1 over 16. These two will be cancelled. So this answer is your 1 over 16. So the question is, find value of tan 9 degree minus tan 27 degree minus tan 63 degree and plus tan 81 degree. It is a JEE question. It is a simple question, but we should know how to approach it or how to start it. It is also a Olympiad math primer based on trigonometry. So the question will first arrange it tan 9 degree plus tan 81 degree. They are complemented to each other, 9 degree and 81. And I'll make it 27 degree and then 63 degree positive. So in the next line, tan 9 degree, tan 81 will be converted to cot 9 degree because tan 90 minus theta is cot theta. It will be tan 27 degree plus cot 27 degree because 27 and 63 make 90 degree. So then I'll convert into sine cos. So this will be sine 9 degree cos 9 degree plus cos 9 degree sine 9 degree minus sine 9 degree 27 degree cos 27 degree plus cos 27 degree sine 9 degree sine 27 degree. So now we'll take LCM and simplify this. So it will be cos 9 degree sine 9 degree sine square 9 degree plus cos square 9 degree, which in the next step will make you 1 sine square 27 degree plus cos square 27 degree. So the numerator is 1. This will be 1 over cos 9 degree sine 9 degree minus 1 by sine 27 degree cos 27 degree. So here we will multiply 2 both in the numerator denominator so that it will be 2 over 2 cos 9 degree sine 9 degree minus 2 over 2 sine 27 degree cos 27 degree. Why? I'll make the double angle formula so that it will be sine 18 degree. 2 sine theta cos theta is sine twice theta. So this will be 2 sine 18 degree minus 2 sine 54 degree. So now you have to depend on your memory because in the examination, entrance examination, you cannot derive what is the formula for sine 18 degree. So sine 18 degree equals to your root under root 5 minus 1 by 4. And to remember, we can you can write the sine 54 degree is the conjugate of this. That will be root 5 plus 1 by 4. That is same as your cos 36 degree. So applying this, 2 by sine 18 degree equal to root 5 minus 1 by 4 minus 2 by root 5 plus 1 by 4. So it will be 8 by root 5 minus 1 minus 8 over root 5 plus 1 Then only a simplification. First you can simplify, you'll get the result. So it will be, I am taking 8 common and rationalizing this. Not rationalizing, I am simplifying. So root 5 minus 1 into root 5 plus 1. Here root 5 plus 1 minus root 5 minus 1. So this will be 8 into root 5 will be cancelled, it will be 2, and here it is root 5 square is 5 minus 1, that will be 4. So 8 into 2 by 4, it will be 2. So answer is your 4. So tan 9 degree minus tan 27 degree minus tan 23 degree is 63 degree plus tan 81 degree is equal to 4. Thank you for watching. Question is, if A equals to sine inverse sine 5, B equals to cos inverse cos 5, find the value of A square plus B square. Sine inverse sine theta equals to theta if theta is your in between negative pi by 2 to pi by 2, or we can say sine inverse x is defined within the range minus pi by 2 to pi by 2. 5 here is given as radian. So 5 radian does not belongs to this interval. So we have to convert this to a value which belongs to this one. Okay. So we know that pi equals to 3.14, 2 pi equals to 6.28 approximately I am writing, and pi by 2 equals to 1.57. So I'll bring this 5 in between, 5 in between, convert this sine 5 in pi by 2 1.5 and negative pi by 2, this in pi by 2 is 1.57. So that means we have to bring this into minus 1.57 and 1.57 in between this. So 5 is your in between pi and 2 pi. It is greater than pi and lesser than twice pi. So when 5 is greater than pi, that means sine 5 is negative because pi plus theta. So sine 5 is negative. The value is negative. So we have to convert this into a positive value in between this one. So we'll write that sine 5 equals to your sine twice pi minus pi with a negative sign. It's negative. We can write this is 2 pi minus 5. So this is same as your sine 5 minus 2 pi. So sine A, which is given to be sine inverse sine 5 minus 2 pi equals to 5 minus 2 pi. And this 5 minus 2 pi, whose numerical value is approximately 5 minus 6.28, 1.28 equals to negative 1.28, it belongs to this interval. Minus 1.57 to your 1.57. So it's correct. So A equals to 5 minus A equals to 5 minus 2 pi. Now coming to B. For B equals to your cos inverse cos 5. We'll apply the logic in the range. Cos inverse is defined when x belongs to 0 to pi. This is its principal range. So cos 5 is your less than 2 pi. So I can write this is cos 2 pi minus 5, and 2 pi minus 5 belongs to this interval because your x belongs to cos 0 is 1 and cos pi is your negative 1. This value is your 2 pi cos 6 point approximately 6.24 minus 5. This equal to 1.6 point how much? 6.28. Sorry, 28 minus so 1.28. So this belongs to this one, so it can be defined. So what I'll write? I'll write B equals to cos inverse cos 5. Without any obstacle, we can write this is cos 2 pi minus 5. Or it is defined, so it will be 2 pi minus 5. So A equals to 5 minus 2 pi and B equals to 2 pi minus 5. Then question is to find the value of A square plus B square. So this equals to 5 minus 2 pi whole square plus 2 pi minus 5 whole square. We know that A minus B whole square is same as B minus A whole square. So we can write A square plus B square equals to 2 times of 5 minus 2 pi whole square. So it will be twice 25 plus 4 pi square minus 20 pi. So A square plus B square is equals to 50 plus 8 pi square minus 40 pi. So actually this was a MCQ question. I have not written all the options. So this is the answer. Basic question. Prove that cot pi over 24 equals to square root 2 plus square root 3 plus square root 4 plus square root 6. Square root 4 we know that it is 2. So it means it is 2. Now there are many methods or various ways of proving this or getting the value of pi by 12. But I am solving with one method. If you like, you can like the video. And here I'll go very uh, slowly because I have to show all the steps. Now I'll apply formula 1 plus cos theta over sin theta. Let us see what is the result on simplification. 1 plus cos theta equals to 2 sin cos square theta by 2. 2 cos square theta by 2. And sin theta is equal to applying the double formula, it will be 2 sin theta by 2 cos theta by 2. On simplification, 2 cancel, cos cancel. I am getting cot theta by 2. cot theta by 2 equals to 1 plus cos theta over sin theta. So this formula I will apply to evaluate cot pi by 12. If theta by 12 equals to your pi over 24, that means theta equals to pi over 12. Pi over 12 means your 15 degree. So I will get cos 15 and sin 15. That's not very difficult to find. Cos 15 degree we may write as cos 45 degree minus 30 degree. So this will be cos 45 cos 30 plus sin 45 sin 30. All this equal to cos 45 is 1 by root 2 multiplies root 3 by 2 plus 1 by root 2 multiplies 1 by 2. So cos pi over 12, that is same as 15 degree, I am getting root 3 plus 1 over 2 root 2. So numerator we got. Next is denominator. Denominator means sine 12 pi by 12. So that is sine 15 degree. So I can write this is sine 60 degree minus 45 degree. I can use this also. So I am getting positive. That's why it will be easier for me. It will be sine 60 degree into sine cos 45 degree minus sine 45 degree multiplies your cos 60 degree. Sine pi over 12 equals to sine 60 is root 3 by 2. So it will be root 3 by 2 root 2 and this is minus 1 by 2 root 2. So on simplification I am going to root 3 minus 1 over 2 root 2. So that is sine pi by 12. Now cot pi over 24 equals to 1 plus cos pi by 12 over sine pi by 12. Let's put the value. So it will be root 3, 1 plus root 3 plus 1 over 2 root 2 whole divided by root 3 minus 1 over 2 root 2. Or cot pi by 24. I am simplifying the right hand side. Here 2 root 2 is LCM. It will be 2 root 2 plus root 3 plus 1 over root 3 minus 1 again over 2 root 2. So these 2 will be cancelled. So ultimately we are getting 2 root 2 plus root 3 plus 1 over root 3 minus 1. Next what? Next we will rationalize the denominator. So cot pi over 12 equals to pi over 24 equals to 2 root 2 plus root 3 plus 1 3 minus 1 multiplies root 3 plus 1. So the denominator will be 2 only because 3 minus 1 a plus b into a minus b. It will be 2. Only the writing the all the terms in the numerator. It will be 2 root 6 plus 3 plus your 3 plus root 3 plus 2 root 2 plus root 3 plus 1 over root 3 square minus 1 square. So this is equal to root 3, it makes 2 root 3, and 3 plus 1, it makes 4. So it will be 2 root 6 plus 2 root 3 plus 2 root 2 plus 4, whole divided by 2. So I'll cancel 2 from each, or dividing 2 each term, it will be root 6 plus root 3 plus root 2, and 4 means it will be root 4. When 4 is cancelled by 2, we are getting 2. 2 is nothing but your square root of 4. So we can write this is square root of 4. As the question demands, you have to write in or express in square root of 4. So we got the result in the form which is asked in the question. Hence it's proved. Question is, find the value of 36 times of, there are 4 products: 4 cos square 9 degree minus 1, 4 cos square 27 degree minus 1, 4 cos square 81 degree minus 1, and 4 cos square 243 degree minus 1. So first I am doing by a method 1. What's it? It is using the complementary angles. We know that cos 81 degree can be written as your cos 90 degree minus 9 degree, that will be sine 9 degree, as well as cos 243 degree can be written as your cos 270 degree minus 27 degree, that will be your minus sine 27 degree. When I'll take the cos square 243, it will be cos square, so it will be square. So there will be no negative sign, it will be positive sine square 27 degree. So rewriting this expression, I'll write 36 4 cos square 9 degree minus 1 into 4 cos square 27 degree minus 1 multiplies 4. Again, this will be sine square 9 degree minus 1 multiplies, this will be sine square 4 sine square 27 degree minus 1. The next line, I'll group them together. One is 4 cos square 9 degree minus 1 into 4 sine square 9 degree minus 1. And here 4 cos square 27 degree minus 1, again multiply by 4 sine square 27 degree minus 1. Then I'll multiply pairwise. So I'll get 36 times, just multiplying this, it will be 16 cos square 9 sine square 9 minus 4 cos square 9 minus 4 sine square 9 plus 1. And the second one, again it will be 16 cos square 9 sine square 9 minus 4 cos square 27 minus 4 sine square 27 plus 1. Again on simplification, I'll get These two I'll take together, taking minus 4 common, cos square 9 plus sin square 9 will makes 1. Here also the same thing, it will makes 1. So it will be 16 cos square 9 degree sin square 9 degree minus 4 plus 1. From the second, the 16, oh, by mistake I have written 9 degree, it should be 27 degree. Sorry. So 16 cos square 27 degree sin square 27 degree, again minus 4 plus 1. Is equal to 36. If I'll take 4 outside, this will be 4 cos square 9 into sin square 9. Applying the double formula, this will be sin 18 degree minus 3. Here it will be again 4 into 4 cos square 27 degree sin square 27 degree minus 3. So this is 36, 4 into sin 18 degree whole square minus 3, 4, it will be sin 54 degree whole square minus 3. So we have to recall the value of your sin 18 degree and sin 54 degree. Sin 54 is nothing but your cos 36 degree. So if I'll apply the values, so it will be 4 sin 18 equals to square root 5 plus 1 by 4, its square minus 3, and here it will be 4 multiplies sin 54 is square root 5 minus 1 by 4 whole square minus 3. So this is equal to, unless you recall this value, we cannot write in this examination, but just please watch to the till the end so that I'll show you a smart way or a shortcut method of solving this problem. So it will be your 4 into 1, 4 will be cancelled, so it will be 5 plus 1, I'm squaring this, plus 2 root 5 by 4 minus 3, because 1 4 will be cancelled with the 4. Second will be this, again this 4 4 will be cancelled, no need of writing, so I'll write 5 plus 1 minus 2 root 5 by 4 minus 3. So 36 into, it will be 6 minus 12, so 2 root 5 minus 6 by 4 into, it will be 6 minus 2 root 5, and it will be minus 6 by 4. Nothing but your 36 into minus 6 square minus 2 root 5 square by 16. This will be 36 multiplies 36 minus 5 into 10. 36 minus 10. 36 minus 20. It will be 16 over 16. Cancel. The answer is 16. Next I am going for the shortcut method. Smart way which you need in the competitive examination. That is your, I am rewriting the question. 36 4 cos square 9 degree minus 1 4 cos square 27 degree minus 1 4 cos square 81 degree minus 1 and 4 cos square 243 degree minus 1. Only one formula you learn to solve this type of question. That is your, I'll write 4 cos square theta minus 1 equals to, I am multiplying, I am converting this into sine, so it will be 4 1 minus sine square theta minus 1, it will be 4 minus 4 sine square theta minus 1, or this is equal to 3 minus 4 sine square theta. Now I'll multiply sine theta both in the numerator and denominator. So in the numerator I am getting 3 sine theta minus 4 sine cube theta over sine theta. The numerator is a familiar expression, that is sine 3 theta. So whole expression can be written as sine 3 theta minus sine theta. Now apply all this. So 36 into, first one will be 9 is theta, it will be 27 sine 27 degree by sine 9 degree. Second one will be your sine 81 degree, 3 times of 27 over sine 27 degree, multiplies, it will be sine 81 into 3 243 degree, theta is sine 81, and last one will be sine 243 into 3, it will be 729 over sine 243 degree. So it will be this to cancel, 81 81 cancel, 243 cancel. So you are getting 36 multiplies your sine 729 degree over sine 9 degree. So this is your sine 29 degree is equal to sine 2 pi plus 9 degree, or 720 degree plus 9 degree, that is same as your sine theta. So 36 into sine 9 over sine 9, that is equal to 1. 36 into 1, answer is 36. So answer is 36. I hope. Here question is 2 sine pi by 8 multiply sine 2 pi by 8 multiply sine 3 pi by 8 multiply sine 5 pi by 8 multiply sine of 6 pi by 8 multiply sine 7 pi by 8. We have to find the value of this. So here we will apply sine 7 pi by 8 is nothing but your sine pi minus pi by 8, that is equal to sine pi by 8. For sine 5 pi by 8, we will apply sine pi minus 3 pi by 8, that is equal to again sine pi sine 3 pi by 8. And for sine 2 pi by 8, is nothing but your sine pi by 4. This value we know, that is your 1 by root 2. And your sine 6 pi by 8 is nothing but your sine 3 pi by 4. Again, this is the supplementary angle of pi minus pi by 4. That will be sine pi by 4. So only you will substitute this value. So twice sine pi by 8, the sine 2 pi by 8, I'll write sine pi by 4. Then sine 3 pi by 8. For 5 pi by 8, I'll write again sine 3 pi by 8. For sine 6 pi by 8, I'll write sine 3 pi by 4, that is again sine pi by 4. And last one is your sine pi by 8. So I'm getting 2 sine pi by 4, that will be sine square pi by 4. Sine square pi by 4 means sine pi by 2 whole, pi by 4 whole square. And I'm getting 2 sine pi by 8. So sine square pi by 8. Next, sine square 3 pi by 8. So sine pi by 4 is 1 by root 2 whole square. 2 into 1 by 2, they will be cancelled. In this step, sine square pi by 8, I'll change this sine 3 pi by 8 for its complementary angle, that will be cos square pi minus 3 pi by 8. Sorry, pi by 2 minus 3 pi by 8. That will be sine square pi by 8. And here it will be 8 pi minus 3. 4 pi minus pi by 8. Cos square pi by 8. And this 2 is cancelled. So next I'll multiply just 1 by 4 and 4 sine square pi by 8 into cos square pi by 8. That is nothing but your 2 sine pi by 8 cos pi by 8 whole square. 2 sine, now applying the double angle, sine theta cos theta into 2 is sine 2 theta. So this will be 1 by 4 into sine pi by 4 whole square. Sine pi by 4 is 1 by root 2. So this will be 4 multiplies 1 by 2 root 2 square 2. The answer is, it's not 4, it was 1 by 4. So it will be 1 by 8. So 2 sine pi by 8 sine 3 pi by 8 sine 3 pi by 8 sine pi by 5 pi by 8 sine 6 pi by 8 sine 7 pi by 8 equals to 1 by 8. Question is, solve cos x plus cos 3x plus cos 5x plus cos 7x equals to 0. So why I am interested in this question? Because I will use golden identity in this question. Yes, golden identity. Let us see what's it. Now I am taking the left hand side of the equation. This is equal to cos x plus cos 3 times of x, cos 5 times of x, and cos of 7x. Then I am taking in pairs and I am using product of sum formula, that will be cos A plus cos B equals to 2 cos A plus B by 2 into cos A minus B by 2. So applying both the pair, I am getting LHS now. Twice cos 3x plus x by 2, that will be 2x, and 3x minus x by 2, that will be x. Or you can write x minus 3x, both are same because cos minus theta is same as cos theta. So 2 cos, it will be 5x plus 7x by 2, and cos 5x minus 7x by 2. So this is nothing but your 2 cos twice x cos x plus 2 cos 6x into cos x. Cos minus x is same as cos x. So net now I'll take common 2 cos x from both the terms outside. So within the bracket I am getting cos twice x plus cos 6x. Again I'll put the formula cos A plus B. So this will be 2 cos x into 2 cos 2x plus 6x by 2, that will be 4x, and cos x plus 6x minus 2x by 2, that will be your cos 2x. So ultimately this equal to 4 cos 2 cos x cos 2x and cos 4x. So we got the expression as cos x plus cos 3x plus cos 5x plus cos 7x equals to 0, means your 4 cos x cos 2x cos 4x is equal to 0. So now making every component or every factor as 0, we can get the solution, but I am going in a different way. What is that? I am proving that 4 cos x cos 2x cos 4x equals to your sine 8x by 2 sine x. So let us see. So if we take the right hand side, sine 8x over 2 sine x. Now putting the formula for sine 8x, you can write 2 sine 4x multiplies cos 4x, double angle formula. Next is sine 4x can be written as 2 sine twice x into cos twice x, and it was there cos 4 times of x by sine x. Again applying the double angle formula for sine 2x, I'll get 2 sine 2x into cos x, sine x into cos x, sine 2x, 2 into sine x into cos x cos 2x cos 4x whole by sine x. Sine x is cancelled, so we are getting 4 cos x cos 2x and cos 4x. So they are equal, we proved. So 4 cos x cos 2x cos 4x equals to 0. That means your sin 8x over 2 sin x equals to 0. This proves that this equals to sin 8x equals to 0. It implies that when sin x is equal to 0, that means x is equal to sin theta is 0, theta is equal to n pi when n is an integer. So we'll write 8x equals to n pi when n is an integer, or x is equal to n pi over 8. The solution of this equation. Question is, can you prove cos pi over 7 multiplies cos 2 pi over 7 multiplies cos 3 pi over 7 equals to 1 over 8. So get ready to learn the trick. I'll start from sine 8 pi by 7. Sine 8 pi by 7 can be written as sine pi plus pi by 7, right? This will be minus sine pi by 7. Pi by 7. Now sine 8 pi by 7 can be written as your 2 cos 4 pi by 7 into sine 4 pi by 7. This is minus pi by 7 we have written. Again I'll expand this one sine 4 pi by 7, or this will be 2 cos 4 pi by 7 this will be 2 sine 2 pi by 7 multiplies cos 2 pi by 7 equals to minus sine pi by 7. Or again I'll expand this one. So it will be 4 cos 4 pi by 7. This will be 2 sine pi by 7 cos pi by 7 and cos 2 pi by 7 equals to minus sine pi by 7. I'll cancel this one. It will be 1. Or now you see this will be 8 cos pi by 7 cos 2 pi by 7 cos 4 pi by 7 equals to minus 1. But I am not getting this one. Oh, now the again magic. You can write cos 4 pi by 7, nothing but your cos pi minus 4 pi by 7, that will be cos 3 pi by 7. Of course, negative because it is in second quadrant. So we are getting minus 8 cos pi by 7 cos 2 pi by 7 cos 3 pi by 7 equal to minus 1, or cos pi by 7 cos 2 pi by 7 cos 3 pi by 7 equals to your 1 over 8. So hence proved. So I hope you liked the trick. So thank you for watching. Don't forget to subscribe if you have not subscribed yet. This question is from a regional maths Olympiad. It is based on trigonometry. Find the smallest integer solution to the equation tan 19x degree equals to cos 96 degree minus sin 96 degree over cos 96 degree plus sin 96 degree. So it is seems to be an easy question. Oh, so let's proceed. Uh, this I'll apply some trigonometric formula on the right hand side to make into a acute angle. Directly we can apply, but let me convert this into acute angle by applying the formula cos 90 plus theta equals to negative sin theta and sin 90 plus theta equals to cos theta. So applying this concept, I can write cos 96 degree equals to negative sin 6 degree and sin 96 degree equals to cos 6 degree. So writing your RHS, it is your cos 96 degree minus sin 96 degree for cos 96 degree plus sin 96 degree equals to your minus sin 6 degree minus cos 6 degree, here minus sin 6 degree plus cos 6 degree. So in the numerator I'll take a common negative and I'll write cos 6 degree plus sin 6 degree or cos 6 degree minus sin 6 degree. So next I'll divide throughout with cos 6 degree. In each term it will be 1, it will be tan. So this will be 1 plus sine over cos is tan 6 degree by 1 minus tan 6 degree, dividing with cos 6 degree throughout. Next we will apply one formula, that is your 1 plus tan theta over 1 minus tan theta equals to tan pi by 4 plus theta. So here it will be 1 plus tan 6 degree by 1 minus tan 6 degree equals to tan 45 plus 6 degree. That will be tan 51 degree. So now writing the equation again, given equation. So equation in the question, tan 19x degree equals to, it has been converted to negative tan 45 plus 6 degree, that will be 51 degree. Again when applied, tan negative theta is same as minus tan theta, so this will be tan minus 51 degree. And I need to make it positive, or I'll add a 1 pi to it, because pi is the period of your tan function, or I can write 180 minus 51, that will be 129. So equals to tan 129 degree. Either you add 180 to this, or you convert 180 plus minus theta is equal to 180. So finally we are getting a simple expression, that is tan 19x degree equals to tan 129 degree. Again, solution for the trigonometric equation in tan will apply if tan alpha is equals to tan beta, then alpha equals to n pi plus beta when n is an integer. So applying this, I can write 19x equals to n pi plus 129. Now I am not putting in degree because I will get the value of x, and instead of pi I'll write it is 180 degree. So this is equal to 180 n plus your 129. We need to find value of n as well as x. Unless you get n, you cannot get x, and n x should be minimum value, so that x is divisible by your 180 n plus 129. That means when this is divided by 19, it should be an integer because n is an integer and x should be an integer value. X is an integer, n is also an integer. So now you will apply your modular arithmetic or arithmetic modular. That means the whole to get to have x as an integer, RHS is an integer. That means 180 n plus 129 over 19 is an integer. What does it mean? It means that 180 n plus 129 should be divisible by 19 or congruent to 0 modulo 19. If it is divided by 19, the remainder should be 0. So we have to think of n. Now to get it in a short way, what I will do, first I am taking this 129. 129 when it is divided by 19, 129 divided by 19, I am getting your 19, 6 times 114, 15 is the remainder. So this congruent to 15 modulo 19. What I am doing, I am just expressing this in a lowest term. So this leaves the remainder 15. Now 180 n is congruent to, now next I'll test for 180. When 180 is divided by 19, I'm getting 19, 9 times 171, 9 is remainder. So this will be 9n modulo 19. That means it will leave remainder 9n. That means now 15 plus 9n, remainder from both the cases, should be divisible by 19. So this should be congruent to 0 modulo 19. So now I think it is easy to get the value of n. N equals to, starting from n is equal to 1, 2, 3, so on. You will find that at when n is equal to 11, I am getting 19 plus 154, which is your 114. That is your congruent to 0 modulo 19, because 19 for 6 times 114. So n is equal to 11. Now coming to x. X equals to your 180n plus 129 divided by 19. So n is equal to 11. So 180 into 11 plus 129 divided by 9. 180 into 11 will be 1980 plus 129 over 19. That will be equals to 2109 divided by 19. The value is very big value, of course, 111. So the value of x is 111. The solution of your the equation x is equal to 1, 1, 1. Thank you for watching. Of the trigonometry equation, the number of elements in set S, theta belongs to closed interval 0 to 2 pi, 3 cos power 4 theta minus 5 cos square theta minus 2 sine power 6 theta plus 2 equals to 0. That means you have to find how many solutions. Options are 10, 12, 9, 8. So let's begin. So here you can see that two terms are in cos and one term is in sine. So first we'll convert this into sine cos. Okay. So what we'll do, I'll write, we know that sine power 6 theta can be written as 1 minus cos square theta power 3. So rewriting the question, 3 cos power theta minus 5 cos square theta minus twice 1 minus cos square theta whole power 3 plus 2 equals to 0. Or 3 cos power 4 theta minus 5 cos square theta. I am expanding this, a minus b whole cube 1 minus cos power 6 theta minus 3 cos square theta plus 3 cos power 4 theta plus 2 equals to 0. So let us simplify. 3 cos power 4 theta minus 5 cos square theta minus 2 plus 6, sorry, it's not 6, it is 2. 2 cos power 6 theta plus 6 cos square theta minus 6 cos power 4 theta plus 2 is 0. So 2 will cancel. Then we arrange them. So we'll get first 2 cos power 6 theta and 3 and minus 6 cos 4 theta will gives us minus 3 cos power 4 theta, and here 1 cos square minus 5 plus 6, this gives us cos square theta equals to 0. So it is simple now. We can take cos square theta outside. So I'll get 2 cos power 4 theta minus 3 cos square theta plus 1 equals to 0. So we split it into two factors. Now either cos square theta is 0 or this term is 0, where I'll take cos square theta as y so that I can split the middle term. So first condition is case 1, cos square theta is 0. So this gives me cos theta equals to 0 and cos theta is equal to 0. This gives us theta is equal to pi by 2 and 3 pi by 2. The interval is 0 to twice pi included. Now case 2, I am taking let cos square theta be y. Directly you can write, but I am writing 2y square minus 3y plus 1 equals to 0. So this is a quadratic equation in y. This gives me y equals to 3 plus minus 9 minus 8 whole upon 4, or y equals to 3 plus minus 1 by 4. This gives us two values. This gives us y equals to 4 plus 4 divided by 4 is 1. y is equal to 1 and y equals to 1 by 2. So what is y? Y was cos square x. So cos square x is 1. That means cos x equals to plus minus 1. And second case, cos square x equals to half. This gives us cos x equals to plus minus 1 over root 2. Now when cos x equals to 1, that means x equals to 0, and cos x equals to minus 1, that means x is equals to pi. One thing we have to remember that here, though the interval was 0 to 2 pi, closed interval, but 2 pi is not considered. So we are taking only x is equal to 0. I am not taking cos x is equal to 2 pi. So there are two values for x, cos x equal to plus minus 1, and when cos x equals to plus 1 by root 2, this gives us x is equal to pi by 4 and x equals to 7 pi by 4. And when cos x is equals to negative 1 by root 2, x equals to 3 pi by 4 or x equals to 5 pi by 4. So let us compile the result. How many solutions are possible now? First it was 0. First x was 3 pi by 2. Then 3 pi by 2. For 0 we got these two values. And for x equal to 1 we got x equals to 0 and x is equal to pi. And for x is equal to 1 by root 2 we got pi by 4 and 7 pi by 4. And for negative 1 by root 2 we get 3 pi by 4 and 5 pi by 4. So there are 8 solutions, not the lines 9 solution. 2 pi will not be considered here. So 4 is the correct answer for this solution. So there are 8 solutions. Question and a trick to solve it. How to evaluate cos 36 degree minus cos 72 degree. So we know that, so cos 36 degree, it is not that simple to calculate in the same way cos 72 degree. So we'll apply some trick to find out this value. So what I'll do, I'll first multiply with its conjugate. So cos 36 degree minus cos 72 degree equals to cos 36 degree plus cos 72 degree is the conjugate of cos 36 degree minus cos 72 degree. So it will be also multiplied in denominator. So in the numerator I'll get cos square 36 degree minus cos square 72 degree. This is your cos 36 degree denominator plus cos of 72 degree. Then we will multiply 2 both in the numerator and denominator. So that I'll get, this will be 2 cos square 36 degree minus 2 cos square 72 degree. Twice cos 36 degree plus cos 72 degree. Then I will apply a formula, 2 cos square theta, 2 cos square theta equals to 1 plus cos 2 theta. So 2 cos square 36 will be 1 plus cos 72 degree. And the next one, if I'll take negative common, it will be 1 plus cos 144 degree. All upon 2 cos 36 degree plus cos 72 degree. So in the numerator, 1 will be cancelled. So we will be getting cos 72 degree minus cos 144 degree. So 2 cos 36 degree plus cos 72 degree. Next, we'll change this cos 144 degree. Cos 144 degree can be written as cos 180 minus 36 degree. So that will be your minus cos 36 degree. And if I'll take minus here, it will be positive. So it will be cos 72 degree plus cos 36 degree upon 2 is cos 36 degree plus cos 72 degree. So we reach the target. This will be numerator denominator cancel. So the answer will be half. So cos 36 degree minus cos 72 degree equals to half. I hope you enjoyed the solution. You learned the trick. So the question is, compute the sum of sine square 4 degree plus sine square 8 degree plus sine square 12 degree plus up to sine square 176 degree. So this is a big series and we have to find the sum, and it is in square, not sine linear function. So let's proceed. So what we will apply formula here, that is your sine square theta, yeah, or 1 minus cos 2 theta equals to 2 sine square theta, or sine square theta equals to 1 minus cos 2 theta twice theta by 2. So I'll apply this formula for each of the term. So first one will be, let me write once the question, sine square 4 degree plus sine square 8 degree plus sine square 12 degree. That means it is a multiple of 4. Last is sine square 176 degree. So first one is applying formula. It will be 1 minus cos 8 degree over 2 plus 1 minus cos 16 degree over 2, 1 minus cos 24 degree over 2, so on up to, and last is very big term, that is 1 minus cos 352 degree by 2. Okay. So from each term I am getting 1/2. So this will be half. How many times it will be? Let us find how many terms will be there. It will be 352. So it is starting from 8, or from here also, from 4 and 176 I can also get it. So a is equal to 4 and an is equal to 176. That means 4 plus n minus 1 into d is again 4 equal to 176, or you are getting 4n equals to 176, or n is equal to 44. So 44 times I'll get half. So the sum of the series will be half into 44, and the rest I can take minus half common, so that in In the series, I'll get cos 8 degree plus cos 16 degree plus cos 24 degree, so on up to cos 352 degree. Okay, now after getting this, we'll apply a very uncommon formula, and you can note down for your Olympiad examination. The sum of, you won't get this question, this formula in many of the book. Sum of sine in an arithmetic progression is equals to sine of nd by 2 or sine d by 2 multiplies cos a plus n minus 1 into d whole by 2. This is the formula. This, for this particular series, a is equal to 8 because it is starting from cos 8 degree. D is again 8. The common difference is 8. 8, 8 is added. And n is equal to 44. We have already calculated. So let's put in the formula. So it will be s equal to, let s equals to cos 8 degree plus cos 16 degree plus cos 24 degree up to cos 352 degree. So s equals to sine n is 44, d equals to your 8 over 2 whole upon sine d is 8, 8 by 2, all this degree into cos 8 plus your n minus 1, it will be 44 minus 1 into 8 over 2 degree. So this equals to, s equals to sine 176 degree. You will cancel, it will be, and here sine 4 degree multiplies cos 8 plus, this will be into 4, 43 into 4, 43 into 4 is your 43 into 4, 172. So this will be cos 180 degree, and this sine 176 can be written as sine 4 degree. 180 minus 1 is 4 degree, sine 4 degree, and this is equals to your cos 180 degree. Cos 180 degree, we know that it is minus 1. So s is equal to minus 1, negative 1. Now whole total sum equals to, total sum is equal to how much it was your, let us go back so that we can see what does the total s equals to your this one. So this is your s, it will be half into s. So let it, I'm writing a s1, I'm getting the sum, it will be 22 minus 22 minus half into s. 22 minus half into your minus 1, that will be 22 plus half is equal to 45 by 2. So sum A means sine square 4 degree plus sine square 8 degree plus sine square 12 degree up to sine square 176 degree equals to 45 by 2 or 22.5, not degree, it is in value. Taking a trigonometry inequality, prove that product of 1 plus a over sin x 1 plus b over cos x is greater than equals to 1 plus square root ab whole square. So I need to prove that left hand on expansion will be 1 plus a over sin x plus b over cos x plus a b by sin x cos x. And about the denominator, right hand side, that means here I'll write two proof. 1 plus twice ab plus twice square root 2ab. Okay. Now if we compare your 1 is equal to 1, first term is no problem. Then I am directly going to this expression. AB by sin x cos x. If I multiply 2 in the denominator and numerator, I am getting 2ab by sin 2x. Now for any value of theta, sin theta is always less than equal to 1. So when sin theta is less than equal to 1, so 1 by sin theta is always greater than 1. On this logic, I can write this is greater than equal to twice AB. That means I compare this with 2AB. So this is greater than 2AB. Now coming to A sin by sin x plus B by cos x. So these are the two terms, A by sin x and B by sin x. I am applying arithmetic mean is always greater than geometric mean. How to write arithmetic mean? This plus first term plus second term is greater than divided by 2. This is arithmetic mean and it is greater than equal to geometric mean. Geometric mean is square root of product of A by sin x into B by cos x. Or this is greater than AB by sin x cos x with a square root. Or I can write A by sin x, B by cos x greater than equal to 2 will be multiplied there, and under the square root again I will multiply 2 both in the numerator and denominator. What's my target? To make sin 2x again. So this will be 2 square root of 2ab by sin 2x. So sin 2x is greater than less than equal to 1. So this will be on the same logic greater than twice square root 2ab. So I am getting this 2 is greater than this one. So now adding this whole thing, 1 plus a sin x plus b cos x plus ab sin x cos x is greater than equal to 1 plus 2 root AB plus 2AB, or 1 plus A over sin x multiplies 1 over B over cos x greater than equal to 1 plus square root 2AB whole square. X be a real number such that m and n are relatively prime positive integers. We have to find sum of m and n, where sine power 10x plus cos x power 10 equals to 11 over 36, and sin x power 12 plus cos x power 12 equals to m over n. So I'll solve this using complex number concept. This I don't claim this is the only method. You can proceed in different method, and if you like you can share. So here let us take let sine square x be y, then cos square x equals to 1 minus y. So the given thing sine x power 10 plus cos x power 10 equals to now y power 5 plus 1 minus y over 5. This is given to 11 over 36. What we have to find out? We have to find y power 6 plus 1 minus y power 6. In terms of m and n, then we will find m plus n. Okay. Now I am taking y equals to half minus z. Let y equals to half minus z, then 1 minus y equals to 1 minus half minus z. That will be half plus z. So this expression given will be your half minus z to the power 5 plus half plus z to the power 5 equals to 11 by 36. Next, I'll take these two expressions and expand using binomial theorem. Plus z power 5 equals to your half power 5, that will be 1 by 32. Next term will be 5c1, 5 combination 1, that will be 5 into 1 by 2 power 5 power 4 and z power 1 plus 5c2, that is 10, half power 3 into z square plus 5c2, again it is 10, 5c 3, it will be 10, half power 2 and z cube, then 5 half power 1 into z power 4 plus z to the power 5. Next, half minus z power 5 will be alternatively positive and negative. So 1 by 32 minus 5 into 1 by 2 z plus 10. And if you understand very well, you can skip this step directly. Also you can write the result taking this plus and minus. My negative, positive, this should be negative. Then your positive 5 by 2 z to the power 4 minus z to the power 5. So when I am taking the sum, it will be half plus 5 half plus z power 5 plus half minus z power 5. This 2 will be cancelled, this is cancelled, and this will be cancelled. 1 by 32 plus 1 by 32, it will be 1 by 16. And second term will be your 2 into 10 into 1 by 2 power 3 is 1 by 8 z square. Next will be 2 into 5 by 2 z to the power 4. This is given to 11 by 36. So I am getting a quadratic equation in term of z square. So it will be 5 z to the power 4, and here 5 over 2 z square plus 1 over 16 equals to 11 by 36. So if you simplify this equation will becomes, I am simplifying, if I multiply your with 16, then I'll get 80z4, or I can directly write 5z4 plus 5 by 2z square plus 1 by 16 minus 11 by 36 is equal to 0. This on simplification gives us z power 4 plus half z square minus 7 over 144 equals to 0. Taking 5 common, you can make 0, or this will be 144 z to the power 4 plus 72 z square minus 7 equals to 0. You can solve by quadratic, or you can simplify with the middle term. So I am doing with the middle terms. Z4 plus 84 z square minus 12 z square plus 7 equals to 0. This is minus 7, not plus 7, writing mistake, sorry. Then this gives us 12 z square, taking common 12 z square plus 7 minus 1 taking common 12 z square plus 7 equals to 0. This gives us one value only, but this is rejected. This will be rejected because z square cannot be negative. So 12 z square equals to 1. 12 z square equals to 1, then z square is equal to 1 over 12. No need of getting your z because we don't need it. So next, coming to your, we'll get your y power 6 plus 1 minus y power 6 is given to m over n. So y is, we have taken as half minus z, half minus z to the power 6 plus half plus z to the power 6 is given to m over n. So let us take again this expression using the binomial theorem. So when I'll expand power 6, it will be your 1 by 64 plus 6c1 is 6, half power 5 z plus 6c2 equals to 15, half power 4 z square 6c3 equals to 20. Then again your 15 half to the power 4 z to the half to the power 2, sorry, z4 plus 6 into half into z to the power 5 plus z to the power 6, and half minus z to the power 6 equals to 1 over 16 minus 6 into half power 5 z plus 15 4z square minus 20 half power 3 z cube plus 15 half power 2 z square 4 plus your, this is minus again, by 2 z 5 plus z to the power 6. So when you are adding them, half minus 5 to the power 6 plus half plus 6z power 6. So alternatively you are getting, so 1 by 64, 1 by 64, 1 by 32. Here 2 into 15 into 1 over 16 z square. Here it will be 2 into 15 into 1 by 4 z to the power 4 and twice z to the power 6. So it will be 1 by 32 plus 15 by 8 z square is equals to your 1 by 12 we have calculated, plus 15 by 2 z to the power 4 is 1 by 44 z square of square plus twice your z to the power 6 equals to 1728. So let's simplify. It will be 1 by 32 plus 15 by 8 plus 1 by 15 by 8 into 12. This is not plus into 12. Sorry. Now I hope you can calculate it yourself. This will be 12. So 3, 5, 3, 4. So 5 by 32. Here it will be 15 over. It can be cancelled with 5, 3, 3, 5, 3, 4, that 8. Then 5 by 96. And this will be your 4. 1 by 864. So total equals to 13 over 54. Then m plus n equals to 67. Answer. Hello friends, I welcome you all to my channel. Today we will solve one trigonometry basic question which is asked in Chinese Olympiad Math examination. Given sec x plus tan x equals to 22 by 7, cosec x plus cot x is m over n. We have to find the value of m plus n. So for this we need only the all trigonometric functions relation. Then we will be able to solve it. First is, given that sec x plus tan x equal to 22 by 7, for this I am taking sec square x minus tan square x is always 1, we know. That means if I'll factorize, this is sec x plus tan x whole multiplies sec x minus tan x equal to 1. Or this is 22 by 7 multiplies sec x minus tan x is equal to 1. So this gives us sec x minus tan x equals to 1 over 22 by 7, that will be 7 by 22. Now we got another relation in sec10. It is given sec x plus tan x equal to 22 by 7. Once I'll add them and once I'll subtract them to get sec x as well as tan x. So by adding, I'll get, when I'll add sec x minus tan x plus sec x plus tan x equals to 7 over 22 plus 22 over 7. So here this 2 can cancel. So twice sec x equals to, if we'll take the LCM and we'll find out, it will be 533 over your 154, or sec x equals to your 533 over 308. Now I'll subtract these two relations. So sec x minus tan x minus sec x minus tan x equal to, I'm subtracting sec x plus tan x minus sec x minus tan x. So this will be 22 over 7 minus 7 over 22. That means subtracting equation 1 from equation 2. This gives us, here sec x will be cancelled. So 2 tan x equals to your 434 over 154, or tan x equals to 435 over 308. So we need cosec x plus cot x. So for cot x we can find from tan x because it is the reciprocal of that. So tan x equals to 435 over 308. That means cot x equal to 308 over 435. Now for cosec x we need sin x. So how to find sin x? I'll find sin x equals to tan x into cos x. Tan x is sin x by cos x multiplies cos x, because tan x I have got 308 and cos x is the reciprocal of your sec x. So it will be 308 over 533. So it will be 435 over 533. So what about cosec x? Cosec x will be reciprocal of sin x. So it will be 533 over 435. So now we got cot x, we got cosec x. This sum is given to be m over n. So cosec x plus cot x equals to 308 by 435 plus 533 over 435. This gives us 841 over 435. So this can be cancelled with 29. So 29 multiplies 29 is 841 and 29 15 is 435. So this is given to m over n, m ratio n. So what does it mean? It means that m is equal to 29 and n equals to 15. The question is about find the value of m plus n. So m plus n is now 29 plus 15 equals to 44. A nice beautiful question on the screen that is based on trigonometry as well as a logarithm. If x belongs to 0 to pi by 2 and logarithm of 24 cos x base 24 sin x equals to 3 by 2, find the value of 24 cot square x. It is given that logarithm of 4 cos x is 24 sin x equals to 3 by 2, writing in exponential form. Twenty-four sin x whole power 3 by 2 equals to 24 cos x. Or this can be written as 24 sin x whole power 3 square root equals to 24 cos x. Or that will be 24 cube sin cube x whole square root equals to 24 cos x. Now squaring both the sides, we get 24 cube sin cube x equals to 24 square cos square x. So 24 square can be cancelled from both the sides. So we are getting 24 sin cube x equals to cos square x. Cos square x can be written as 1 minus sin square x. So we get 24 sin cube x plus sin square x equals to 1. And how to solve it? We should remember x is from pi by 2. So I am taking some rational root. Testing with rational roots. I'm putting let sin x equals to 1 over 3. Then 24 1 by 3 whole cube plus 1 by 3 square. Let us check whether it is 1 or not. 24 multiplies 1 by 27 is 1 by 9. Simplification, it will be 8 by 9 plus 1 by 9, it's 1. So this satisfies. And sin x equals to 1 by 3, verifying sin inverse 1 by 3, whether it comes in this interval or not. Yes, it falls in interval. 0 to pi by 2. So it satisfies. So sin x equals to 1 by 3. Then sin square x equals to 1 over 9. Then cos square x equals to, because we need 24 cot square x, so we need cos square x. Cos square x equals to 1 minus 1 by 9 equals to 8 by 9. Cot square x equals to square x over sin square x. That will be 8 by 9 over 1 by 9, 8. Then the question is find the value of 24 cot square x. So this will be 24 multiply here 8, 192. From trigonometry, if 6 tan inverse x plus 4 tan inverse 3 times of x equals to pi, compute x square. So here first we can recall the formula, that is tan of a plus b equals to tan a plus tan b over 1 minus tan a into tan b. Let us see how we can apply this formula, or why I have written this formula. It is given that 6 tan inverse x plus 4 tan inverse 3 times of x equals to pi. Now dividing throughout, I can get 3 tan inverse x plus 2 tan inverse 3 times of x equals to pi by 2. Now taking tangent function both the sides, we'll get tan of 3 tan inverse x is 2 tan inverse 3 times of x equals to tan pi by 2. We know tan pi by 2 equal to infinity. So here I'll put the formula tan a plus b. So it will be tan a, it means tan 3 tan inverse x, plus tan b whole over 1 minus tan a into tan b. So tan 3 tan inverse x, so tan 2 tan inverse 3x equals to infinity. Infinity means we know that denominator is 0. So comparing the denominator, you can add 1 minus tan 3 tan inverse x and 2 tan inverse 3x equals to 0. Or 3 tan inverse x and 2 tan inverse 3x equals to 1. Next we'll put some inverse trigonometry formula, that is 3 tan inverse a equals to tan inverse 3a minus a cube over 1 minus 3a square. First I'll put this formula, and 2 tan inverse b equals to tan inverse twice b over 1 minus b square. And here b I'll put here 3 times of x. So it will becomes tan inverse 3x minus x cube over 1 minus 3x square, and second one will be tan inverse 2 into 3x over 1 minus 9x square equals to 1. So ultimately I'm getting 3x minus x cube over 1 minus 3x square multiplies 6x over 1 minus 9x square equals to 1. So let us simplify further. So it will be 6 times of x multiplies 3x minus x cube equals to 1 minus 3x square into 1 minus 9x square. So it will be 18x square minus 6x to the power 4 equals to 1 minus 12x square plus 27x to the power 4. Or this gives me 33x to the power 4 minus 30x square plus 1 is 0. So this is a quadratic equation in x square. Since we need x square, so no need of calculating x, directly I can get x square. So x square is equals to, now applying the quadratic formula, I'll get 30 plus minus b square, 30 square 900 minus 4 into 30. So 900 minus 4 into 33, 133 over here 33, 2 into 33. So we are getting 30 plus minus, it will be square root of 8, 7. Here 66. And on simplification I'll get 15 plus minus 8 square root 3 over here 33. So x square has two values now. One is 15 plus 8 root 3 over 33, and x square equals to 15 minus 8 root 3 by 33. We'll check both the values for left hand side of the equation. The equation was 6 tan inverse x plus your 4 tan inverse 3x equals to pi. If we put x square equals to 15 plus 8 root 3 33, numerically in the left hand side we won't get your 3 pi on the right side. So this does not satisfy the equation, as it gives the value 3 pi instead of pi. But x square equals to 15 minus 8 root 3 by 33 satisfy the equation. Let's JEE Main trigonometric equation, how to solve it. If alpha is the solution of 4 cos alpha plus 5 sin alpha equals to 1, and alpha is greater than negative pi by 2 to pi by 2, less than pi by 2, then the value of tan alpha equals to 10 minus square root 10 over 6, 10 minus square root 10 over 12, square root 10 minus 10 over 6, square root 10 minus 10 over 12. So let's start the question. Answering 4 cos alpha plus 5 sin alpha equals to 1. So let's divide throughout by cos alpha. We'll get 4 plus 5 tan alpha equals to sec alpha. Now squaring both the sides, we get 16 plus 25 tan square alpha plus 40 tan alpha equals to sec square alpha. We know next term will convert the sec square alpha as tan. So it will be 16 plus 25 tan square alpha plus 40 tan alpha equals to 1 plus tan square alpha. Now taking all the things to left hand side, we'll get 24 tan square alpha plus 40 tan alpha plus 15 equals to 0. So this is a quadratic equation in tan alpha. So we'll divide throughout by no division. Directly we'll go for the trigonometric formula. So tan alpha equals to negative 40 plus minus 40 square 1600 minus 4 into 24 into 15 gives 1440 whole over 2 into 24. So we are getting tan alpha equals to minus 40 plus minus square root 160 over 48. Simplifying, we'll get tan alpha equals to your minus 10 plus minus, if we'll take 4 common, it will be square root 10, 16 outside over 12. So now let us check alpha is greater than negative pi by 2 and less than pi by 2, then which value will be fitting in this interval? It will be negative 1. It cannot be both negative because it is negative pi by 2 to pi by 2. So the value will be matching, or it will be within the interval equals to minus 10 plus square root 10 over 12. So let's check the answer. Which one is the answer? Square root 10 minus 10 by 12. So 4 is answer. Compute the sum of tan 1 over cos 2 plus tan 2 over cos 4, so on up to 10 2 power n over cos 2 power n plus 1. So here no degree, nothing is mentioned. So let's see how we can proceed. I'm writing the general term, that is your, if I'll write tan alpha over cos twice alpha, all are double of that if you observe. Then next I'll put the formula for cos 2 alpha, that will be 1 minus tan square alpha over 1 plus tan square alpha. Then it will be tan alpha 1 plus tan square alpha 1 minus tan square alpha. Now on simplification it will be tan alpha plus tan cube alpha per 1 minus tan square alpha. Now again further simplification here, I'll write this as tan alpha equals to 2 tan alpha minus tan alpha plus tan cube alpha per 1 minus tan square alpha, and I'll make it 2. One is 2 tan alpha per 1 minus tan square alpha, and here negative common, it will be tan alpha minus tan cube alpha 1 minus tan square alpha. So ultimately this is becoming 2 twice alpha over 1 minus tan square alpha minus, here I'll take tan alpha common, then it will be 1 minus tan square alpha over 1 minus tan square alpha. Here these two terms will be cancelled. So we are getting 2 tan alpha by 1 minus tan square alpha minus tan alpha. The first term is tan 2 alpha, we know. So tan twice alpha minus tan alpha. So each term equals to tan 2 alpha minus tan alpha. Then we'll go for telescopic sum. That means first term will be tan 1 over cos 2. It will be tan 2 alpha. So tan 2 into 1, that will be tan 2 minus tan 1. Coming to second term, tan 2 over cos 4 equals to tan 4 minus tan 2. So it will be third term. It will be your tan 4 over cos 8 equals to tan 8 minus tan 4. And coming to the last terms, last term will be tan 2 power n over cos 2 power n plus 1 equals to tan 2 power n plus 1 minus tan 2 power n. So it is obvious that the last but one term must be your started with tan 2 power n, which will be cancelled with this, minus tan 2 power n minus 1. So adding all these terms, we'll get this 2 will be cancelled, here will cancel, and your this will be cancelled, this will be cancelled with the last one. So here this term will be left and the first term will be left. So the sum will be adding all the terms, your tan 1 over cos 2 plus tan 2 over cos 4 plus tan 2 power n over cos 2 power n plus 1 equals to tan 2 power n plus 1 minus your tan 1. So answer is 10 power 2 power n plus 1 minus tan 1. JEE Main inverse trigonometry. Given that the inverse trigonometry function takes the principal values only, then the number of real solutions of sine inverse 3x over 5 plus sine inverse 4x over 5 equals to sine inverse x. And the choices are given 0, 1, 2, 3. We have to find how many solutions it has. So recalling the formula for sine inverse or any inverse trigonometry functions, we know that sine inverse A plus sine inverse B equals to sine inverse A into 1 minus B square root plus B multiply square root 1 minus A square. So here it is given that sine inverse 3x over 5 plus sine inverse 4x over 5. I can simplify this as sine inverse 3x by 5 square root 1 minus 4x by 5 square plus 4x over 5 into square root 1 minus 3x over 5 square. So we are getting sine inverse 3x by 5 square root 25 minus 16x square by 25 plus 4x by, there is no square root here as a bracket here, 4x by 5 the square root of 25 minus 9x square by 25 equals to sine inverse x. Now I'll take sine function both the sides. Taking sine functions both the sides, we'll get sine inverse 3x into square root 25 minus 16x square by your 5 into 5 25 plus 4x multiplies 25 minus 9x square over 25 equals to your sine inverse sine inverse x. So left hand side will remain only in x. Sine of sine inverse is same as theta. So 3x square root 25 minus 16x square plus 4x multiplies 25 minus 9x square over 25 equals to your x. Because on the right side sine of sine inverse equals to x. Only now simplification, it will be x I can cancel from both the sides. So we are getting 3 into square root of 25 minus 16x square plus 4 into 25 minus 9x square equals to your 25. Now we can take one square root left hand side, one square root right hand side, and whenever we are cancelling this x, it is giving one solution, x is equals to 0. So one solution we got here. Now squaring both the sides, I'll get, this will be a 25 minus 16x square equals to 25. I'm taking irrational to one side so that it will be easy for us. 25 minus 9x square. Then I'll square both the sides. So I'll get 9 into 25 minus 16x square equals to 625 plus 16 into 25 minus 9x square minus 2500 200 into square root 25 minus 9x square. So again on the simplification, I'll get here 225 minus 144x square minus 625 minus your 400 plus 144x square equals to negative 200 square root 25 minus 9x square. Let us see, these two will be cancelled, or ultimately I am getting your how much? It will be 800, negative 800. So negative 800 equals to negative 200 square root 25 minus 9x square. This is 4, negative negative cancel. So 25 minus 9x square equals to 4 square root. Squaring both the sides, I'll get 25 minus 9x square equals to your 16. This gives us 9x square equals to your 9, or x square equals to 1, or x is equals to negative and positive 1. So previously we got one solution, that was 0, x is 0, x is equal to 1, and x is equals to negative 1. So there are three solutions. So let us check which one is answer. Your 4 is answer. The answer. Okay. Question on the screen, JEE Main, inverse trigonometry. This can be a maths Olympiad challenge also. If cot inverse alpha equals to cot inverse 2 plus cot inverse 8 plus cot inverse 18 plus cot inverse 32 up to 100 terms, then the value of alpha equals to 1.03, 1.00, 1.01, 1.02. So let's proceed. So first, let us generalize the terms it is given in the series. One is, first term is 2, next is your 8, next 18, next 32. So this is in a pattern. 2 means 2 into 1 square. 8 equals to 2 into 2 square. 18 equals to 2 into 3 square. And 32 equals to 2 into 4 square, so on. Or the general term is your cot inverse 2n square, and you have to find the summation of cot inverse twice n square from 1 to 100. This is the question. So let's write this term cot inverse 2n square equals to tan inverse over 2n square. I don't claim this is the only method. We can get other method also. Tan inverse. Now I am multiplying 2 both in the numerator and denominator. To find a general formula for the series, so 2 over 4n square. In the next term, next step, I'm doing this 2 over 4n square minus 1 plus 1. Then what I'm doing, I'm trying to make a series. That's why I'm doing so many things. So this is tan inverse. Here I am writing 2 means your 2n plus 1 minus 2n minus 1. And here I am writing 2n 1 plus 2n minus 1 into 2n plus 1. I hope it is clear. That was 1 plus 4n square minus 1. So I convert into 2n minus 1, 2n plus 1. And the numerator, I add a 2n and subtracted a 2n, and I convert this as 1 plus 1. That means here the step is your tan inverse 1 plus 2n plus 1 minus 2n in this way. And here 1 plus 2n minus 1 into 2n plus 1. Now why I am doing, in the next step it will be clear. So this equals to tan inverse. You will take this is A and this is as B. 2n plus 1 is A and 2n minus 1 as B. So we are getting tan inverse. This is your A minus B over 1 plus AB. This is nothing but your tan inverse A minus tan inverse B. So this will be tan inverse 2n plus 1 minus tan inverse 2n minus 1. So now coming to the series. So the series was 1 to 100 cot inverse twice n square. So we converted into 1 to 100 your tan inverse 2n plus 1 minus tan inverse 2n plus 1 minus 2n minus 1. Then we'll go for telescopic sum of all the values starting from 1 to 100. So what will the first term? It will be, if I'll put 1, it will be 3 and this will be 1. So first term will be your tan inverse 3 minus tan inverse 1. When I'll put n is equal to 2, it will be 5, this will be 3. So tan inverse 5 minus tan inverse 3. So what will be the third term? That means when n is equal to 3, it will be your 7 minus tan inverse 5, so on. And whatever the last term, it will be tan inverse 201 minus tan inverse 199. So if we'll observe, all the terms will be cancelled. You'll find that only tan inverse 1 will be left, and here tan inverse this will be left. So the final sum is answer equals to tan inverse 201 minus tan inverse 1. So you can practice this type of sum. You can see a question from JEE Main which is based on trigonometry as well as properties of the determinant. The solution of the equation for x greater than 0 and less than pi, 1 plus sine square x, sine square x, sine square x, cos square x, 1 plus cos square x, cos square x, 4 sine 2x, 4 sine 2x, 1 plus 4 sine 2x equals to 0. The solutions are pi by 6, 5 pi by 6, 7 pi by 12, 11 pi by 12, 5 pi by 12, 7 pi by 12 and pi by 12, pi by 6. So first let's observe the determinant so that we can apply the property to get your the determinant value easily. So what I am doing, I am applying the property R equals to R1 plus R2. That means I am adding these two rows and writing in row 1. So it will be 1 plus sine square x plus cos square x, and the second column it will be sine square x plus 1 plus cos square x, and third column it will be sine square x plus cos square x, and the second row will be as it is, cos square x, 1 plus cos square x, cos square x. Third row will be 4 sine 2x, 4 sine 2x, and your 1 plus 4 sine 2x. I don't claim that this is the only method. You can apply other properties also. So adding these two, I'm getting sine square plus cos square is 1. So this will be 2. Here also 1. This will be 2. And sine square plus cos square is 1. And second row as it is, sine 2x, 4 sine 2x, 1 plus 4 sine 2x equals to 0. Yes, you are guessing correct. Then next we will apply column 1 minus column 2. Applying the property column 1 equals to column 1 minus column 2, so that we will get so many zeros. It will becomes 2 minus 2 0, and 2 this will be 1. First column will be cos square x minus this one, so it will be negative 1, and here subtracting you will get 0, and here it will be as it is, 1 plus cos square x, cos square x sine 2x, 1 plus 4 sine 2x. This is equal to 0. So first column I am getting 2 zeros, so I can expand with this. It will be 1 into 2 multiplies 1 plus 4 sine 2x minus 1 into 4 sine 2x equals to 0. So this gives us 2 plus 8 sine 2x minus 4 sine 2x equals to 0. Four sine 2x equals to negative 2. or sine 2x equals to negative half. Here it is given that x is greater than 0, less than pi, and you are getting negative half. That means 2x is in either third quadrant or fourth quadrant. So 2x equals to your 7 pi by 6, pi plus pi by 6, that time it will be negative, pi plus pi by 6, and this will be your pi 2 pi minus pi by 6. Again, fourth quadrant it will be negative, so it will be 11 pi by 6. 2 pi minus pi by 6. So x equals to your 7 pi by 12 and 11 pi by 12. So let us check the answer. There will be 2 is the answer. You can see one JEE Main question on the screen, which is based on trigonometric solution. The number of solution of the equation e power sine x minus e minus twice e power negative sine x equals to 2. The options are 1, 0, 1, 2, and more than 2. Let's proceed. So if I'll take e to the power sine x as t, and t must be greater than 0, then only it will be defined. So this rewriting this equation in form of t, the equation was e to the power sine x minus twice e to the power negative sine x equals to t. Writing in it is 2, not t. I am writing in this equation in t. It will be t minus 2 over t equals to 2, or I'll get t square minus 2 equals to twice t, or rearranging t square minus 2t minus 2 equals to 0. Now applying the quadratic formula, t equals to 2 plus minus 4 plus 8 over 2. So this is equal to 2 plus minus square root 12 by 2. This will be 2 plus minus 2, 3 over 2. So this will be 1 plus minus square root 3. So t I got 1 plus minus square root 3. Now we have taken that t is greater than 0. So t equals to 1 minus square root 3 does not satisfy it. So t equals to 1 plus square root 3. Square root 3 is approximately 1.73. So it is approximately 2.73. So we got e to the power sine x equals to 2.73, and we have to find out how many values are there for sine x. Now taking log both the side to base e, equals to log e 2.73. So here it is sine x, and right side equals to, we know that log e 2.718 equals to 1, because e equals to 2.718, so on. So 2.73 is greater than this. So sine x we are getting greater than 1. So this value is greater than 1, so sin x is greater than 1. But sin x is never greater than 1. So the answer will be there is no solution, or number of solution is 0. You can see a question on the screen, that is Maths Olympiad challenge from trigonometry, and you have to solve the question cos power 10x minus sine power 10x equals to 1x belongs to 0 to 2 pi. So I can rewrite this expression as cos power 10x equals to 1 plus sine power 10x. Now we'll see both the analyze both left hand side and right hand side. We know that cos x is always less than equals to 1. So cos power 10x is less than equals to 1. And similarly sine x is less than equals to 1. So sine power 10x is less than equals to 1. Now LHS is less than equals to 1. But when you go to right hand side, RHS, since sine power 10x is greater than 1 and 1 plus less than equals to 1, it should be less than equals to 2. It is, or it is greater than 1. So RHS is your is greater than equals to 1. So it is only possible when LHS equals to RHS, that means both are equals to 1. So we are getting cos power 10x equals to 1 and sine power 10x equals to 0. So when cos power 10x equals to 1, cos x equals to plus or minus 1. And when sine x equals to 0, x equals to your 0, x can be pi, x can be 2 pi. So cos 0, if we verify now, cos power 10x minus sine power 10x equals to 1. So x 0, this is 1. When x is equal to 0, this is 1 minus 0 equals to 1. So verify. If it is pi, cos pi is negative 1, negative 1 power 10, again 1, cos sin pi is 0, this is 1, verified. And when cos x is equal to 2 pi, so it will be again 1 minus 0, it is verified. So what is the generalization? That means cos power 2nx minus sine power 2 times of nx equals to always 1 when n is a positive integer, or 2n is even power. Solution is always n pi. So now can you find if cos power nx minus sine power nx equals to 1 if n is odd? the solution. Or you can have another question. If it is question is sine power nx or 10x minus cos power, let me take 10x. This is for practice. You can find cos power 10x is equal to 1. What will be the solution? You can see a question from JEE Main based on inverse trigonometry. Find alpha if sum of all solutions tan inverse 2x over 1 minus x square plus cot inverse 1 minus x square by 2x equals to pi by 3 is alpha minus 4 over root 3. This is the sum, and x belongs to minus 1 to 1. That means x is greater than negative 1, lesser than 1. X is not equal to 0. We have to find the value of alpha. So here there is two conditions. One is x belongs to minus 1 to 0 and x belongs to 0 to 1, all open interval. So when x is greater than 0, cot inverse 1 minus x square over 2x is your same as tan inverse 2x over 1 minus x square. At that time, we can write the equation tan inverse 2x over 1 minus x square plus tan inverse again 2x over 1 minus x square equals to pi by 3, or twice tan inverse 2x by 1 minus x square equals to pi by 3, or tan inverse 2x by 1 minus x square equals to pi by 6. Tan inverse 2x over 1 minus x square, we know that this is the formula for 2 tan inverse x equals to pi by 6, and tan inverse x equals to pi by 12. So x is equal to tan pi by 12. Tan pi by 12 equals to tan pi by 3 minus pi by 4. So this equals to tan pi by 3 minus tan pi by 4, 1 plus tan pi by 3 into tan pi by 4. Tan pi by 3 is equal to root 3 minus 1 over 1 plus root 3. So we will simplify the value. X equals to root 3 minus 1. Rationalizing the denominator, root 3 plus 1 into root 3 minus 1 is equals to 3 plus 1 minus 2 is root 3 over 3 minus 1. That is 4 minus 2 root 3 over 2. So this gives us 2 minus root 3. So x equals to 2 minus root 3, that is one solution. When x is greater than 0. When x is less than 0. So that time cot inverse x is not equal to pi minus tan inverse x. This is not equal to tan inverse 1 by x. So what's it? Cot inverse x is the time equals to pi plus tan inverse 1 by x. So applying this, we'll write that cot inverse 1 minus x square over 2x when x is less than 0 equals to pi plus tan inverse 2x over 1 minus x square. So coming back to the equation, tan inverse 2x over 1 minus x square plus cot inverse 1 minus x square by 2x will becomes tan inverse twice x over 1 minus x square plus pi plus tan inverse twice x over 1 minus x square equals to pi by 3. This gives us 2 tan inverse 2x over 1 minus x square equals to pi by 3 minus pi, that will be minus 2 pi over 3, or tan inverse 2x over 1 minus x square equals to minus pi by 3, or 2 tan inverse x equals to minus pi by 3, or tan inverse x equals to pi by 6, negative pi by 6. So x equals to, your negative pi by 6 means negative 1 by root 3. So now sum of the solution is, one is x is negative 1 by root 3 and x is equal to 2 minus root 3. Solution 2. 2 minus root 3 minus 1 by root 3 equals to your alpha minus 4 by root 3. So you will simplify, this will be alpha equals to, because this is again your same as minus 4 over root 3, so 2x alpha is equal to 2. So this is answer. On the screen you can see a very interesting question from JEE Main. Let a1 equals to 1, a2, a3, a4 be consecutive natural numbers, then tan inverse 1 over 1 plus a1 into a2 plus tan inverse 1 over 1 plus a2 into a3 plus so on up to tan inverse 1 over 1 plus a2021 a2022 is, 4 options are given. We have to find which one is correct, or maybe many are correct. Answer 1 is pi by 4 minus cot inverse 2022. 2 is cot inverse 2022 minus pi by 4. 3 is pi by 4 minus tan inverse 2022, and 4 is tan inverse 2022 minus 4. So here we have to recall one formula, that is tan inverse your a minus b over 1 plus a into b equals to tan inverse a minus tan inverse b. Now a1 is 1 given a2, a3 are consecutive numbers, then a2 equals to 2, a3 equals to 3, then your a2 minus a1 is same as your a3 minus a2. This is same as your a4 minus a3. This is same as your a2022 minus a2021. That is difference is 1. So the numerator 1 we can convert in these terms. First term you can observe tan inverse 1 over 1 plus a1 a2 can be written as tan inverse a2 minus a1 over 1 plus a1 a2, because a2 minus a1 is difference is 1 consecutive natural numbers. So this can be, we can write tan inverse a2 minus tan inverse a1. Similarly, second term will be written as tan inverse a3 minus a2. So writing the whole question, tan inverse 1 plus 1 plus a1 a2 plus tan inverse 1 over 1 plus a2 a3 plus tan inverse 1 over 1 plus 2021 into 2a2022. So first term equals to tan inverse a2 minus a1. So second term will be in this pattern, I'll write. It's very sorry, it will be tan inverse a1. Then from second term I'll get tan inverse a3 minus tan inverse a2 plus tan inverse a4 minus tan inverse a3, so on. Last two term will be tan inverse 2022 minus tan inverse a2021. So if we'll see minutely here, these two will be cancelled, So only tan inverse a2022 and tan inverse a1 will be left. So a1 equals to 1. Replacing this, we can write tan inverse a2022 minus tan inverse 1. Tan inverse 1 is pi by 4. So the answer is tan inverse 2 minus pi by 4. So let us check the answer. So it will be how much? Tan inverse 2022 minus pi by 4. So 4 is the answer. Fourth part is the answer. Now let us check whether any other answer is there. So here A2022 is same as your A2022, because these are the natural numbers 1, 2, 3, so on. So A2022 as term will be 2022. So it can be written in this way. Now tan inverse 2022 can be written as pi by 2 minus quad inverse 2022. So the whole thing is, the answer is can be written also in another way. Pi by 4 is same as your pi by 2 minus cot inverse 2022 minus pi by 4. Then pi by 2 and pi by 4 taking together, this will be pi by 4 minus cot inverse 2022. So let us check whether this answer is also there. Yes, first one is also there. So both 1 and 4 are correct. Some trigonometric formula you can note down. It will help you to solve the problem. Please subscribe the channel if you have not done it. Like the video and share among your friends. Thank you for watching.